Now, whenever any communication happens in TCP, right? TCP stands for Transmission Control Protocol. Whenever any communication happens in TCP, we always use these flags for the communication, right? To tell this, to tell some information or give some information, right? So there are general 6 flags which are used in the communication. The very first one is synchronization flag. Now, synchronization flag means that it will synchronize the two devices, right? Now, synchronize means whenever any legit TCP communication starts, it will always start with a synchronization flag, right? And it so that it is used to initiate a TCP connection. Whenever any genuine TCP communication starts, it will always start with a synchronization flag. Now, synchronization flag is used in something called three-way handshake, right? So you have two devices, right? These two devices, they want to communicate with each other. So the client will send a send flag, a synchronization flag to server. Hi server, this is uh, my name is client and I want to connect with you, right? TCP server will acknowledge that I have received your synchronization flag and will also send a synchronization flag that okay, if you want to connect, I also want to connect with you. And the client will then send an acknowledgement, and this process is called three-way handshake. And after this process, your communication starts. Yes. So that is where your synchronization flag is used. Then next thing that we have is acknowledgement flag. Now, when we talk about acknowledgement flag, it indicates that the sender has received the data and the sender is acknowledging it, right? So after receiving the data, the sender sends the acknowledgement packet to confirm the receipt, right? So here you can see after every SYN we are sending acknowledgement that yes, I have received it, right? So that's a kind of receipt that you get. Then we have finish flag. Now finish flag is used to end a communication, right? Whenever we are communicating, so we are starting, whenever we start our session, like these sessions which are going on, whenever we start this session, we greet each other, then we start. That's three-way handshake. Then when we are done, so we will say goodbye to everyone, right? So that's a generous way of closing the communication, right? Or you can say finish flag is used to gracefully terminate a TCP connection, right? Now finish flag is used in something called four-way handshake. Four-way handshake means client will send a finish flag that I want to close this connection. The server will send acknowledgement that okay, you can close the connection. The client will again send a finish flag. The server will send the finish flag again, and then client will send acknowledgement, and the connection will be terminated. That's your four-way handshake, right? That's a generous way. You are telling the person that yes, I want to close this communication now, right? Now, next thing that we have is reset flag, right? Now, when we are talking about the reset flag means connection should be reset immediately or abruptly closing the connection. Right now, if I close this meeting, end this meeting for everyone, that will be reset, abruptly closing the communication. I'm not telling the target person that I'm going to close the this communication, but I'm directly closing that communication, right? That's your reset flag. Whenever we are sending data, we always send data in frames, right? Or chunks. We don't send the whole data at a single go, right? The data goes in packets. With every packet, you attach a push flag, right? For pushing the data towards the receiver, right? So it is used when data should be pushed to the receiving application or the user without any delay, right? Now, why there is a need of push flag? Why the data is not going without the push flag? So what happens? Let's say there is some data, right? Now you are sending a message, hello, right? The frame or the buffer size, or you can say the window size for this is 100 bytes, right? It can take data up to 100 bytes, but you have given only 5 bytes, right? So you have given only 5 bytes. Now using those 5 bytes, will will those 5 bytes be going towards the target? No. Now think of it. Uh, there is a transport vehicle, right? Let's say bus, right? A local bus you have taken. Now you are inside the bus. No one else is there, right? No one is there in the bus. Will the bus move? Will it take you only to the destination? Only one person? No. The bus driver, the bus conductor will wait for the bus to get full, right? They will wait for all the seats to be reserved, and then they will move, right? Same like that, when you are sending some data, so if the size is 100 bytes, it can take up to 100 bytes of data, and you are sending only 5 bytes of data, so then the data will not move. So for that you use push flag, right? So that the data will be pushed towards the target. Otherwise it will keep on waiting for these 100 bytes to get full. Yes, that's push flag. Then we have urgent flag. Now what urgent flag does? Utilize indicates that the data contained in the packet should be processed urgently, right? So it is used for urgent data like interrupt signals that need to be prioritized, right? So if there is any data that needs to reach first, and there is a sequence like this is packet number 1, 2, 3, but if packet number 3 needs to be processed first at the target, so we will use urgent flag also with packet number 3, so that packet number 3 will first, then later packet number 1 and 2 will be sent. So these are the 6 general flags. ECE, it stands for explicit congestion notification echo, right? It is used for network congestion notification, right? So when a device or host detects congestion, it sets the ECE flag to signal this to the other host. So one device will be telling other device that there is a congestion in the network, right? There is one more CWR, right? Now CWR means congestion window reduced. So it indicates that the sender has reduced its congestion window, right? So it is used in conjunction with ECN flag, right? To manage, it is used for managing the network congestion, right? So these are some of the flags, other flags that are used when congestion happens in the network, right? Now, when we talk about scanning, right? What is scanning? Scanning means we are scanning the network and finding out IP addresses, open ports, the device operating system, right? So its objective is to discover live host, the devices which are up and running in the network, and open ports of live host. Then it discovers the operating system and the system architecture. It also tells you the services running on those hosts, and it will also find out the vulnerabilities in the host, right? Now, we generally use NMAP, right? To do what? To find out open ports, services running, right? Now, NMAP. What is NMAP? NMAP stands for Network Mapper, right? Now, it is a very powerful open source tool which is used for network discovery and security auditing. And it is widely used by uh, security professionals, network administrators, and enthusiasts to scan and map the network. So Nmap, it provides lots of functionalities like host discovery, port scanning, service enumeration, vulnerability detection, right? All those things are there. Now, when we are talking about Nmap, so we have to understand how it works, right? So Nmap, it works in 5 steps, right? First, it does ARP ping sweep. Now, what do you mean by ARP ping sweep? So ARP stands for Address Resolution Protocol, right? Right. Now, this address resolution protocol, what it does, it resolves your IP address to MAC address, right? IP address is the logical address of your network, and MAC address is the physical address of your device. Now, if there are few devices in the network, let's say these are the 3 devices, right? For those who are not aware about ARP, right, all these devices are connected to the network. Now, device A wants to send some data to device C, right? So the IP address is 192.168, let's say 12.111. This is 12.12 and this is 12.13, right? Now, A wants to send some data to C, so A knows what is the IP address of C, right? So A will do what? A will send a broadcast message in the network saying that anyone having IP address 192.168.12.12, send me your MAC address. Now B will get that message, right? B will say, no, my IP address is not written in the message. B will drop it. C will receive that message. C will say, yes, the IP address written in the message is mine. So C will reply back to A with its MAC address. And that's how your address resolution protocol works. Right. Now here, second term is ping. Ping is a utility which is used for finding out if the target host is up and running or not. Right. Now when we are talking about our ping sweep, right? So combinedly what that is. So our ping sweep is a network scanning technique which is used to find out or discover active devices on the local network. So our ping sweep, it operates at the data link layer and it can detect devices even if they have ICMP ping responses disabled, right? So how it works, it basically send ARP request, right? So it will send ARP request to each IP addresses within the whole range or whole subnet, right? Then there will be ARP reply, right? So devices on the network with the requested IP addresses will respond with the reply containing their MAC addresses, right? So the whatever scanning tool you are using, it will be collecting the ARP replies and it identifies the active devices based on the MAC addresses received, right? Then it does DNS lookup and reverse DNS resolution. So DNS lookup means that let's say you have given a domain name to the Nmap tool. So and it will try to find out the IP address of it. Reverse means if you have given IP address, then it will give the domain name of it. Right? Then the open ports. Right? After finding out open ports, it will also run NSE. NSE stands for Nmap scripting engine. Nmap scripting engine means Nmap has a predefined list of scripts. Right? Now those scripts are helpful when you are doing enumeration, right? Enumeration means finding out more information. So let's say if I'm writing scripts, So you can see there are lots of scripts. Let me show you. This is from some other tool. Yeah. So if you see, here are the scripts, right? Now these scripts are related to different protocols or different services like SSL, SSH, SOCKS, then SMTP, SNMP, SMB, right? What these scripts do, they help you to find out more information, or they also help you to find out vulnerabilities, right? So let's say we have these scripts, right? Now HTTP is there, right? So for HTTP, there is a script with the name http-waf-detect.nsc. Now, if you will execute the script against a web application, it will find out if the web application is using a web application firewall or not. Then, if you run HTTP 1CVE to 2017-8917, right? What it will do, it will try to check the HTTP version running in the target application if it is vulnerable to this exploit or not. So it will tell you if it is exploitable or not. So that is your NSE. So it will NMAP will automatically pick up the scripts. You just have to use the switches, and it will automatically pick up the script, right? And it will run those general scripts on the target. When we are talking about NMAP, so NMAP should be having some options or switches that we call, right? Then we also have to know how Nmap finds out if it is an open port or closed port. Yes. So let me show you the options, and then we'll see how it finds out the open ports. Now, if you see here, these are the switches of Nmap, right? Hyphen V is used for verbosity, right? Verbosity means if you want detailed output. Now, detailed output, it depends on you how much you want, because you can go to level 3. So hyphen V, hyphen double V, hyphen triple V, right? That's for verbosity. Then hyphen PN, right? Now the thing is that when you start doing scanning, right? The very first thing that you check is whether the host is live or not. When we start the steps of scanning, we always check if our target is up and running or not, right? Now, let's say there is a machine in my network, right? This is my VMware, and inside that there is a machine. Now, think of it as a one operating system is Kali Linux, and other operating system is this, right? So this operating system is locked, right? This operating system is locked, right? I don't have username and password of this operating system. So how can I find out if there is a device in my network? How, but physically we may be in different place, uh, a bit far away, right? How can I find out if that device is up and running or not? Or how can I find out the IP address of that device? I'm not aware about the IP address or anything. So whenever we check whether it is like, if our host is up and running, right? How to check whether the host is live or not? How you can find out? We can use ping, but we don't have IP address, right? Tracert or traceroute. Yes, we can use that, but still we don't have IP address. What can I use then? So there is a thing called ARP scan, right? Everyone knows address resolution protocol. Now, the first thing, I have to find the IP address of my network, right? Once I have the IP address of my network, I will get to know from where my subnet is starting. So my subnet is starting from 192.168.12.0, right? Now, if it is starting from 12.0, so I will scan my subnet. For that, I'll write arp scan 192.168.12.0/24. Slash 24 is the subnet mask. It will tell how many devices to scan. So slash 24 means 255.255.255.0. So that means you have to scan from 192.168.12.0 till 12.255 only, not more than that. Now, when I press enter, I was expecting that in the output there will be only one IP address, right? But there are four IP addresses. Now, out of these four IP addresses, how can I find out which one is the IP of my target machine? Because the thing is that ARPScan never gives you the IP of its own in the output. Like ARPScan will not give you the IP of Kali Linux in the output. So out of these four IPs, what are these IPs? From IP address, Osvaldo, you can find out the location. With MAC address, you can only find out which manufacturer which manufacturer's MAC address is there. Now, for finding out the IP address out of these four, we have to understand concepts. First thing, I'm inside VMware. VMware is a software which is used for virtualization, right? So I can install virtual operating systems, right? So in my Windows, I have installed VMware. Inside VMware, I've installed this Kali Linux and other operating systems, right? One. This dot one will be the IP address will be of the base Windows, right? So the Windows machine, the Windows laptop which I have. So VMware understands or names it 192.168, whatever your subnet is, and dot one if you have installed VMware, right? So dot one is my Windows, right? Then dot two. Dot two is the gateway. Gateway means a kind of virtual router, right? Because the operating system that I'm running inside VMware, the virtualized environment, they need like internet also, right? So my laptop is getting internet from my router, but how will operating system inside the VMware will get the internet, right? So dot two is acting as a gateway and it will take internet from Windows, and through this gateway, the internet will be given to all the machines inside. Then we have 12.254, right? Now this 254 is the server which is running, right? So DHCP stands for Dynamic Host Configuration Protocol, and that is the service which provides IP addresses or which distributes the IP addresses to different devices in the network. So the management of IP addresses is done inside VMware also. Yes. Now the management is done by DHCP server. So there is a server running with VMware which is distributing the IP addresses to different operating systems in my VMware, right? So that DHCP server also has an IP address, and the IP address is .254, right? And then we are left with only one IP, and this is the IP of my target machine, right? So what we have done, we have found the IP address of the target machine, and we have sent address resolution protocol packets to everyone in the network, and the target machine replied back with its MAC address, and here we can see it. So does that mean the target machine is up and running? Yes. Now, if I already have done ARP, is there any need to perform ARP ping sweep? ARP ping sweep is doing what? It is finding out whether the target machine is and running or not. Thing for me, so there is no need to perform this step. And for blocking ARP ping sweep, we use the option -pn, right? Then we have hyphen sn. Hyphen sn does what? Hyphen sn blocks everything and it does, right? So same like ARP scan, you can also use nmap hyphen sn option to find out the IP addresses which are up and running in the network. The thing is, this nmap ping sweep, it will also give you the IP address of your own Kali Linux in the output, right? Rest of the things are same, right? Dot one, dot two, dot 151, dot 254, right? Then hyphen n for blocking the DNS lookup. Not specifically DNS lookup, but reverse DNS lookup. If I have already given the IP address of the network, so there is no need to find out the domain, just do the scanning and find out the open ports. That's what I'm telling to nmap, right? Then next option is hyphen p. By hyphen p, you can specify a port, right? Specifying a port means hyphen p23. I want to scan only port number 23. So I have written hyphen p23, or I want to scan 23, 25, 29. So you can give it like this also. If you want to scan a range, so you can write hyphen p23 to 50, right? So it will scan all the ports starting from 23 till 50, right? So when you want to specify port, then you can use hyphen p. Otherwise, you can use hyphen p hyphen. Now hyphen p hyphen does what? It scans all the 65535 ports. So port starts from 0, it goes till 65535, which makes it a total of 65536 ports, right? Port 0 is referred to as reserved port, right? That's why Nmap does not scan port number 0, right? So it scans from 1 to 65535. Then hyphen SV for service version. Now let's say if my service running is HTTP, right? And let's say I go to internet and I deploy it for HTTP. So it's not giving exploit, but it is telling, right? Different types of exploit, right? In Windows 10, this exploit is there, right? This is for Windows 10 21H1 version, right? HTTP protocol stack remote code execution vulnerability, right? So the thing is that if I look for the vulnerabilities for HTTP only, right? There will be lots of vulnerabilities, right? There will be thousands of them. Yes. Now, if there are thousands of vulnerabilities present, which one to specific? So I will be finding out the service version, that which version of HTTP is running, right? And then I will be specific that I want to find out the exploit code for which version of HTTP, right? So that's your service version. Then there is hyphen SC, right? Hyphen SC is used for running well-known scripts. So I have shown you all the scripts of Nmap, right? So I'm telling Nmap to automatically pick up the general scripts for all the ports which are open and run those scripts so that I can get more information. Yes. Then hyphen O for finding out the operating system, right? That what is the target operating system, which operating system it's using, right? Next we have hyphen IL. Now what it does, it scans a list of IP. So whenever we are doing scanning, let's say I've given you a contract of doing pen testing and I asked you that you have to do pen testing of these 100 devices, right? So if I'm doing scanning of those 100 devices, will I be writing the nmap command 100 times for every single device? No. What I will do, I will put all of them, all the IP addresses in a list in a text file. Then I will use -il option and give the text file to the Nmap so that it can basically find out all the open ports. Yes. Then next we have is -f. -f is used for fragmentation. Basically, it's used to pass the firewalls. So rather than sending the whole code or whole data once, we are fragmenting the data into smaller parts and then sending it, right? Then -f, uppercase F, right? So that's called fast scan, right? So it will scan 100 well-known ports. So I'm not saying that it will scan port number 1 to 100. It will scan random 100 well-known ports, right? Then there is -OA. -OA, it gives you the output in three different formats, right? Like XML format, HTML format, or NMAP format, .nmap extension, right? Then we also have -MTU. So MTU stands for maximum transmission unit, right? So it fragments the packet into multiple of 8. So if you want to break your packets into smaller parts, so you can write -MTU 64. So it will break your packet into 64 parts, right? These are the options that we use with Nmap. Now, next thing is how we find out, or how Nmap finds out that if the port is open or closed, how it decides, right? So there are different types of scans. The first scan that we have is Nmap-ST, which is called TCP full connect. Now in TCP full connect, what happens? The same process of three-way handshake happens. So let's say there is device A is the attacker, B is the victim, and A wants to find out if port number 80 of B is open or not, right? Now if I want to find out if port number 80 of device B is open or not, so what I will do, A will send a send flag to port number 80 of B. If port number send an acknowledgement, that means port is open, right? Then A will send acknowledgement. Now here what's happening, it will basically, this is a three-way handshake. So the connection between A and B will be established. A found that port number 80 is open, but still the connection is established between both the devices. So after this, A will send again a packet which is called reset ACK to B to abruptly close the communication. Nmap-SS, which is called half open or half connect or stealth scan. That means port is open. So then what I will do, I will send a reset. Yes, I will directly send the reset flag. Connection will be uh, closed, and then no connection will be established, right? So I found the port is open, and I also haven't established any connection, right? Next we have FinScan. Now in FinScan, what we are doing, we are sending finish flag to port number 80 of B. Now if port number 80 of B is replying nothing, it's not giving any reply, that means port is open. Perfect. Now Nmap sends fin flag two times from two different ports just to make sure that there is no reply. If there is no reply, that means port is open. But why is that? Why it says that if there is no reply, how it finds out the port is open? So the reason is that whenever we start session every day, right? So how we start the session? By greeting each other. What if I start the session saying, bye guys, take care? There will be no reply, right? So the thing is that we are starting the connection, and we are starting the connection with finish flag. Now B will say that there is no connection of mine going with A. So which connection A is trying to close? Yes. And that's what? That's your finish flag. That's why there is no reply. So B does not know what to reply back. If someone starts a session with finish flag, so what to reply back? It does not have anything, because in TCP IP suite, it's not written, right? That if someone sends a finish flag, what to reply back to them. Then we have next Xmas scan and map-sx. Now here what we are doing, we are sending three flags: fin, push, and urgent. Finish, push, and urgent. Now when I'm sending these three flags, out of these three flags, none of the flag is used to start a communication. So B still does not have any reply for it. And if B is not replying back, that means port is open. It's not stopping. It's listening to our packets, but it does not have a reply, what to reply back, right? So that is what? That is Xmas scan. Now what if the port is closed? If the port is closed, whatever flag you want to send, you can send. It will send a reply back, and the reply will be reset acknowledgement. If it is sending reset acknowledgement, nmap will think or find out that yes, this port is closed. Now the question is, what do you understand by open port and closed port? I'm saying that if port is open, what does that mean? It means that there is a service which is running on the port, right? Now it depends whether that service is there for accepting the connections or not, but there is a service which is using this port. If I'm saying closed port, so it means no service is using that port, right? Now let me start Wireshark, right? So Wireshark is what? Wireshark is basically a packet capturing tool, right? So I can put a display filter ip.addr equals to 192.168.12.151. Now that is the IP address of my target machine. So it will only capture the packets which are going towards the target machine. Now what if I write nmap-st -pat and the IP address. So nmap-st is TCP full connect. So there what will happen? Send, SYNAC and ACK, and then after that reset ACK. So it says port number 80 open HTTP, right? Now let's see. Can you see the names? First packet send flag, then send ACK, then third acknowledgement, and then reset acknowledgement. Nmap-ss stealth scan, right? Send ACK and reset. Now when I did open to port number 80 from two different ports, 61434, 61436 to port number 80, but there is no reply. That means port is open. Yes, that's what we discussed. Then next we have is SX. Now nmap-sx fin push and urgent. Can you see fin push and urgent here? Two times from two different ports, but there is no reply. So that means I have given you the proof that whatever we are learning, that's correct. Now next thing is I'll do a nmap scan on the target machine, right? Find out all the open ports, save the output in offsec.xml file, right? So you can see I've written hyphen v hyphen n hyphen p n hyphen sv sc hyphen p hyphen, right? And it found lots of open ports. So let's wait for it to give the output. So it's running the scripts. That's why it's taking a little bit of time, right? Then we'll see what output it gives, what information it is giving us. Yeah, sure. Here's the command. NMAP -v for verbosity, -n for blocking the DNS lookup, -pn for blocking the ping sweep, -sv for service version, sc for running the default scripts, -p for scanning all the ports, all 65535 ports, and -ox to save the output in XML file. Now, if you see, it has given the output, right? Now, the output is very difficult to read here, right? That's why I have saved it in XML format. Now, I will convert it into HTML format. And after converting it into HTML format, we'll open it with Firefox. Now, if you see, this is the report which is given by NMAP. And here we can see port number 21 open, right? Service running is FTP, right? The reason it said that the port is open because it replied back with send ACK, right? Product is VSFTPD, which version of FTP, and 2.3.4. Then it executed two general scripts for FTP. The first script is FTP-NN, right? Which is anonymous FTP login allowed, which says, right? And then FTP syst, right? Which will give you the status of the FTP server running in the target machine, right? So it says connected to 192.168.12.131, logged in as FTP, type as Sky, no session bandwidth limit, session time second is 300, control connection is plain text, data connection will be plain text, VSFTPD 2.3.4, secure, fast and stable, end of status, right? Then same like that, other ports are also there, right? For other ports also it is giving information which port is open and which version is running, right? So this is how you perform the scanning and find the information. Now what we have to do, let's say I want to exploit a vulnerability, I want to find out a vulnerability, then exploit it and then get the access of the machine, right? Access of the target system. Now the thing is that how to exploit. First, we have to look the scanning results. Now, these results, what they are saying, first, this script is saying anonymous FTP login allowed. That means you can log into the FTP server of the target machine as a user, right? You can give the username as anonymous and maybe you'll be logged in and maybe you'll find some information, right? So let's try that. I will write FTP space IP address of the target machine. It's asking for name, anonymous, password, anonymous, and it says login successful, right? Now, when it is saying login successful, if I do ls here, it's not showing in. It just says here comes the directory list. Send OK and done. No data, no information, nothing. It's not showing any directories. You can connect, but you don't have privileges to see anything or do anything. Now we are not able to find out any information here, so let's exit from here. Now I want more information, which will help me in exploiting the vulnerability in this device, in this machine. So what can be done? At this step, when your scanning is not giving proper output, you have to go for enumeration. Enumeration means interacting with the machine, finding out more information. Now, when we discussed about those scripts of NMAP, we have to find out those scripts again. So I've written locate nmap slash scripts and grep FTP. So I only want the scripts for FTP, right? So these are the scripts, only these ones for FTP, right? Out of these scripts, which one you think will help you out and give you more information about FTP? So the product version is VSFTPD, right? Here there is a script related to VSFTPD backdoor.nse. Yes. So I'll copy the name of the script and I'll write the command nmap-p21, the name of the script and the IP address, right? Hyphen script specifies the option that after this you will be naming the script. So if you see, it has given the output port number 21 TCP open, the name of the script FTP VSFTPD backdoor vulnerable. If it is so VSFTPD version 2.3.4 backdoor again. So it says the state is vulnerable and it is exploitable. So you can exploit the vulnerability, and it is showing you the date when the exploit was released, and after that it is showing you exploit results. That after you have exploited the vulnerability, if you write the command ID, right? So you will be getting UID as 0 and GID as 0, right? Now UID means user ID, GID means group ID. Whenever you are in Linux, if your UID is 0 and GID is 0, you are root user, otherwise you are a normal user. Yes. Now, we found that it is vulnerable, it is exploitable, but how to exploit the vulnerability? So when we talk about exploitation, right, we have a framework which goes by the name Metasploit framework. So Metasploit framework is what? It is an open source pen testing platform which is used to identify, exploit, and validate the vulnerability, right? And it is widely used by security professionals or ethical hackers and researchers to test the security posture of the systems and networks, right? Now, it is used for exploit development, vulnerability detection, payload delivery, post exploitation, right? And it has extensive library of modules for various tasks like scanning, exploitation, reporting, many things, right? Now, for starting the Metasploit framework, you always write MSF console, right? And Metasploit framework will be loaded. Now the Metasploit framework is loaded, right? And you can see this is the banner of Metasploit framework. You can change the banner, just write the banner command and it will be changed to something else, right? If you don't like the banner, this one is fine. Now in this Metasploit framework, there are different modules, right? The very first module that we have is exploits. So exploit means taking advantage of a vulnerability. Now this is what, when we talk about this exploit, there are 2294 piece of codes which can take advantage of different vulnerabilities. Then there are 1201 auxiliary. Auxiliaries are what they help you, right? Now, when we are talking about auxiliary, how it helps you in enumeration, and what is enumeration? Basically, what happens Whenever you want to find the information or whenever you want to get something easily, then you use auxiliary. So let's say I have a list of usernames and password. There are 100 usernames, 100 passwords, right? That now if you try all the combinations of username and password, then what will happen? It will take a lot of time, right? So 100 multiplied by 100, that means 10,000 times you will be typing the username and password, and then one of them will work. So there are auxiliaries present to which you can give the username and password, and it will automatically try that username and password in the target. Okay. Then next we have post, right? Now post means these are post compromise modules. Once you have compromised the vulnerability, so once you have exploited the vulnerability in a system, after that what you will do, you will do internal reconnaissance, and then you will move from one device to another lateral movement you will do, right? So after compromising the vulnerability in a system, then after that, what things you will do? You will find out more vulnerabilities, or you will gather information, or you will connect the internal systems to some external systems, right? So for that you have to route the IP of the internal systems to the an external system and then connect to that IP, right? So that is post. After compromise of a system, then what you will perform, those are 409 modules. Then we have payloads. What is a payload? Now, when we talk about payload, payload means that this is the uh, basically the one who gives you access of the system. Now think of it. Let me draw it here. This is the attacker's device, right? This is the victim device. Now victim device has a vulnerability, so attacker sent victim an exploit code, right? Now once the exploit code goes to the victim system, it's exploited. The vulnerability is exploited, but you're not getting anything out of it. Why we are hacking into things? To get the access of the things, right? Exploit means exploit will find a vulnerability, it will take advantage of the vulnerability, it will open the door in the target machine so that you can send your payload, right? So with the exploit code, you have to send the payload code also, right? Now what that payload code will do, it will basically tell that what to do next, right? So maybe the payload code will say that like exploit happened, payload code got inside the system, and then the payload will say that create a reverse connection with the attacking machine. So it will get connected to the attacking machine, right? Or payload will open a port here in the victim machine so that attacker can connect to that port and get the access of the system. Perfect. Then we have encoders. Now the payload that I'm sending, that payload can also be a malware. Yes, it can be a malware, right? Now that malware will be detected. So if I'm sending a virus to your system or a Trojan to your system, will your Windows Defender detect it? Malware will be detected by your system, your Windows Defender, right? So for bypassing those security, what we do, we encode our payload, right? We encode it using some encoders. Now the most famous encoder that is there is Shikata Ganai, right? So Shikata Ganai is basically an encoder which will convert the payload into different formats so that it cannot be understood by any security tool in between. After that, we have NOPs. Now, NOPs are interesting things. NOPs, it stands for no operations, right? Now, no operations, what does that mean? Now, no operation, these kinds of things are used when you are using, uh, let's say, when you are performing the attacks like buffer overflow attacks, right? So what happens? NOP is a filler or padding used, right? So you want to run two processes uh, at a single time. Like once you are writing a command, you want that I want to execute two commands, but it should be understood that by the memory, by the RAM, that these are two different processes. That should also happen because RAM, if you give two different processes at the same time, then it will be a problem. Yes, process one and process two at the same time cannot be executed by the RAM. So what you do, you give process one, then you fill the between portion with NOPs, no operations, and then you also give the process two. So when it will load in the memory, so process one will execute, then there will be NOPs. That means nothing will happen for a period of time. So memory will understand that this is a filler, and then process two starts. So memory will understand this is a process number two. That's where NOPs are used. So if I show you, let's say I'm writing a command ID and who am I? I want to execute both of the commands. I want the output of both of the commands at the same time. If I execute that, it says command not found because these are two different processes and I am putting two different processes at the same time on the memory, right? So what I will do, I will put a semicolon in between and I've written ID who am I. So it shows the output of both of the commands, right? So this semicolon in between, it is acting as a NOP here. Nothing is happening for a period of time, right? And then last we have evasion. These are the techniques which are used to bypass your firewall, IDS, IPS kinds of things. Now the thing is that when we are talking about the exploitation, right? So we have to search for a specific exploit. So that's why we need the service version also, right? Search for VSFTPD, right? 2.3.4. And the type of thing I want to find out is exploit, right? I want to find out exploit for this. So when I press enter, it shows me that there is an exploit present for that backdoor, right? Now, this is an exploit code. First, we have to pick up the exploit code. So for picking up, you will write use, right? I will using this code. So use, either you give the whole name of it or you give the index number. So for this, the index number is 0, but I'm picking the full name. I've written the full name, right? Then the payload code. This time it says no payload configured defaulting to this. So it automatically picked up the payload code here. Yes. Now, for whom you want to run this. So you'll write options and it shows you the options that you need to give. So there is an option which with the name rhost, right? Rhost means remote host. That means the target host. So here you have to set the IP. So you will write set rhost as 192.168.12.151, the IP of the target machine. Once it is done, write exploit and the exploit will start. So it says backdoor service has been spawned, UID 0, GID 0, that means your root. Found command shell, session 1 opened, and then you can write slash bin slash bash hyphen I, and you can see it shows root at infosec. So you are root user. If you write the ID command, UID 0, GID 0, you hacked inside the machine and you got the access. So that's how you do the exploitation and you exploit the vulnerability.